confidence intervals for the difference in means. A hypothesis test tells us whether a difference exists, but a confidence interval goes further. It tells us how big the difference likely is, providing a range of plausible values for the true difference mu1 minus mu2. The confidence interval formula has three components. First, the point estimate, the difference in sample means x bar 1 minus x bar 2. Second, the critical value t star from the t-distribution with appropriate degrees of freedom. And third, the standard error, which quantifies the precision of our estimate. The standard error uses the same formula as in the hypothesis test, combining the variance from both groups. Let's compute the 95% confidence interval for our cholesterol example. We know the mean difference is 34.75, the standard error is 13.56, and degrees of freedom is 19. The critical t-value for 19 degrees of freedom at alpha equals 0.05 is 2.093. Plugging in 34.75 plus or minus 2.093 times 13.56 gives us 34.75 plus or minus 28.38. So the 95% confidence interval is 6.37 to 63.13 milligrams per deciliter. We are 95% confident that type A men have, on average, between 6 and 63 milligrams per deciliter higher cholesterol than type B men. Let's visualize this confidence interval on a number line. The number line shows possible values for the mean difference. 0 represents no difference between the groups. Our 95% confidence interval stretches from about 6 to 63, with the point estimate of 34.75 in the center. Since the interval does not include 0, we can conclude there is a statistically significant difference. Here is the key rule for interpreting a confidence interval for a difference. If the interval excludes 0, the difference is statistically significant. The entire plausible range is on one side of 0. But if the interval includes 0, we cannot rule out the possibility that there is no real difference. The result is not statistically significant. To summarize, the confidence interval equals the point estimate plus or minus t star times the standard error. It tells us the range of plausible values for the true difference. If the interval excludes 0, we have a significant result. If it includes 0, the difference is not statistically significant.